Hello everyone, this is the fourth video in our QEMU series. Today we are diving into the QEMU system mode emulation. Specifically, we will emulate Raspberry Pi 3B, and we will see what QEMU can and cannot do when it comes to emulating an entire system. The idea behind emulating a system is that QEMU try to emulate an entire setup that includes CPU, RAM, hard disk, buses, and many other things. However, QEMU can only emulate systems or boards that are already defined in its library. So this is one of the limitations of QEMU. If you want to add your own system or own board, then you need to modify the source code. To get started, we need to install a QEMU system in our machine. As you can see here on the left, I'm using a virtual machine that's running Ubuntu. And in order to install a QEMU system, we can use the package manager. When I hit enter here, you can see I have already installed a QEMU system on my machine. So once the installation finished, we can check out all the different architecture that QEMU supports. So when I hit enter here, you will see a list of binary. Each binary represents an architecture. For example, this represents x86 64. We have also for MIPS. We have for ARM 64 and ARM 32. So you can think of each binary as a specific microprocessor. Let's take, for example, the AVR, which is the architecture behind the very famous Arduino. So if I type the following command, so QEMU system AVR, then dash m this m for machine and question mark, or I can use help here, and I hit enter here. This will list all the supported board, and as you can see here, the Arduino Nano, which I guess almost everyone is familiar with this board. If we want to get more specific, we can check also the CPU that this board supports. So I specify the machine as Arduino Uno, and then I add dash CPU question mark, and you will see here the list of the CPUs that we can use. So this is for AVR. You may be wondering now where this happening or how this the implementation happening, and that's a fair question actually. So all the detailed implementation is actually we can find it on the QEMU main GitHub repository. So here I am inside the hardware directory, and if I go to the AVR here, again this is the Arduino, and we can check, for example, the Arduino C, and here the C code for the implementation of Arduino board. You can see QEMU Arduino boards. Actually, not only for AVR, inside the hardware directory, there are subdirectories, which each one represent an architecture. You see here for the ARM, and inside each subdirectory, you can see the C code for all this implementation. So everything happening here on the and in the hardware directory, and that's why I said if you want to add your own board, then you need to modify the source code and specify also the architecture for your specific board. Okay, so now I can do the same for ARM architecture, because in this video we are focusing on the ARM architecture. So if I list the supported machines or system here, we can see there are many for ARM. However, I'm only interested in the Raspberry Pi, so I will grab only on the Raspberry Pi. So at the same command, I'm only getting the Raspberry Pi. We can see There is Raspberry Pi 0, 1, 2, 3AB, and 3B. And I can do the same, for example, for the 32, ARM32. We can see that there is support for Raspberry Pi 0, Raspberry Pi 1AB, and Raspberry Pi 2B. So for this video, I'm focusing only now on the Raspberry Pi 3B. So okay, if we want to check the CPUs that this Raspberry Pi 3B support, we can again specify the machine as Raspberry Pi 3B and then dash CPU question mark, and you can see there are many CPUs. I will be using Cortex A57. Okay, so what do we need to emulate? If we think about emulating a Raspberry Pi, we can run this command, and what we will get here, we will get a Raspberry Pi 3B, but actually this is no difference than you are holding a bare Raspberry Pi in your hand without anything running on it. So this is not enough. We need to see how we can make or take advantage of that and install our own system on that. So let's think, what usually do we do when we use actual Raspberry Pi? We need an SD card, and of course we need the kernel, Linux kernel. So QEMU also help us in creating this SD card. So what I will do, for example, I will run this command. So here I'm creating an SD card image with the size of 32 gig, and then I need to as well create the partition table. Running this command, I'm just creating the partition table, and because of the way how a Raspberry Pi 3B boot, we need two partition. The first partition, this is the primary, will have the FAT32 and the size 256. This is for the boot. And then I need also to specify the second partition, which will be for the root file system there. So, and if I list now SD card, you see now I have an SD card, but this is still not finished. Now we have kind of emulating of physical SD card. Next, what we need an operating system. And for this demonstration, I will grab the operating system from the Arch Linux. If you go to the main page of Arch Linux, they have a Linux for multiple platform. They have even for Raspberry Pi for 32 version 7, and also for the 64 architecture. So I am interested in this Raspberry Pi version. So we need to download it and extract it. So to do that, I already created a directory called Arch Linux. So this is the command. So yeah, I created a directory called Arch Linux ARM64. Then I use wget in order to get the Arch Linux ARM Raspberry Pi, and then you need also to untar it. So this is takes a few minutes to save the time. I already did it. So just by running those commands, you will have everything inside the Arch Linux ARM64. So if I run Arch Linux here, you can see everything is here. So now we have the SD card, we have the Linux kernel and all the necessary, the binaries, the boot, all the file system here. So in a real setup, the next step would be to flash the SD card, and that's exactly what we will do here. However, we will do it in a different way. Actually, there are multiple ways to do it, but in this video, I will use the loop device to handle the flashing process. So for example, I will run this command. Let me clear here, and then so this command will set up a loop device for the SD card image, which allows me to access any partition on the SD card as if they were on a real disk. So once I hit enter, that will be executed. Then my next step is I need to know setup dash A, I need to know the loop device number associated with the SD card image, and as you can see here, it's now is in the loop 14. So now I know the number. Then we need to format the first partition as FAT32 file system. I can use this command, and as you notice here, I choose the loop device 14, then partition 1. That's for the boot directory. And then the second one, I will use this command. So now the loop 14 partition 2, that will be formatted as ext4 file system here. So yes, now my SD card is formatted and ready. I can print actually the partition. So here we have the primary partition FAT32. As I said, this is for the booting the system, and the rest will be on the ext4. Okay, next we will mount these two partition on the mount directly. However, I need to create two directory on the mount. The first one, I will call it the boot, and the second one, I will call it the root file system here. So now if I list the on the mount, you will see I have two directories. And of course, now we need to mount. What do I need to mount? I need to mount the loop 14 partition 1 on the boot, and I need to mount the partition 2 on the root file system. So 1 on the boot, 2 on the root file system. Okay, so now here is the important step. I will be using rsync instead of using copy to copy the file from the Arch Linux boot to the mount boot, and the rest to the root file system. The reason I'm using rsync, because rsync usually preserves the permission of the files, but more importantly, with the -a flag, it will also preserve the symbolic link. And this is very important for especially the init process, which usually has a symbolic link. So I will use this command. This is for the boot. Usually the boot is okay. You might not need the rsync, but I will use it for both of them. Now I'm copying everything inside the boot to the mount boot. This is the first one. And the second is I'm copying everything else to the root file system. I could exclude the boot, but yeah, I'm not doing it now. So now everything will be copied to the root file system. This might take a few seconds, but if I list like mint boot, so you will see I have everything. Most importantly, this is the boot script. This will be executed by U-boot during the booting process. I could do the same for the root file system. Also, you will see everything here. Now let's do a little bit cleanup. So I will just unmount everything I used, root file system, and also I need to delete the loop device. I'm using symbol commands also to remove all. All right, now everything is ready. We have set up everything. Let's get QEMU running. However, the command is very long. So what I will do is I will create, let's run it using a script. So I will create a script. Let's call it emulate Raspberry Pi 3b.sh. And I will put the command here. So what's happening in this command? I'm using QEMU system architecture 64. Then I'm specifying the machine as Raspberry Pi 3B, memory 1 gig, and specifying the CPU, the number of core, and then here, this is the most important, kernel, and then a path to where the kernel 8 image. This is, as I said, inside, you find it inside the boot. And then here also the DTB, which also you need to specify. By the way, there are multiple DTB there, but you need to choose the 3 because here we are emulating Raspberry Pi 3. Then the drive, it will just point out where our SD card, and it will be kind of SD interface. And here I use this two kind of trick because I wanted to forward all the logs and the interaction with the machine to my terminal. So I don't need to emulate a keyboard and interact with the QEMU GUI. I prefer to stay on my terminal, and actually also because the GUI caused some problem. So I prefer this to be run on my terminal. Okay, so let's save this script, and then let's make it executable, and let's see what happened when we run now this script compared to our previous run to the QEMU. So once I hit enter, maybe let me go to full screen here. As you can see here, I think I can zoom in, zoom in, zoom in. So here, Ubuntu start, find Ubuntu script. So is the script I mentioned before. Now it's executing, setting up the environment, finding the kernel, and then it will move the kernel to where to start executing. So everything gets happen in now in the background. This might takes a few minutes actually. I'm just waiting until we see kernel start, and then you will see the logs in both terminals happening. And then I will stop the video, come back when we are at the login in prompt. You see kernel start, and now you see all the logs. As I said, this will take a few minutes. I will stop recording, come back when it's done. So back again, you see now we reached the logging prompt. This is on my terminal. This is on the GUI. I prefer on the terminal, make it faster. So here, if I type root for the username and root for the password, you would see that now I logged in. Also, that takes a little bit some time, but yeah, actually finally I'm here. ID, I'm the root, and if I want to check the operating system release, you could see that, okay, I'm using Arch Linux for ARM. So everything is ready. As I said, I don't use the GUI. Even here, I didn't use a keyboard, so I can't type here. When I try to use the keyboard, there was some issue emulating it. However, in general, I don't use it. I prefer my terminal. Also, it's faster. So here you go. In this video, we showed a simple example how you can emulate Raspberry Pi 3B and using Linux operating system on it. Actually, there are some specific Linux operating system for the Raspberry Pi on their main page, but I prefer to show one from the Arch Linux. I don't know, maybe in your work you might need to install different operating system, and that's why I went for the Arch Linux as an example here in this video, but you can also use anyone from the Raspberry Pi website. However, there are some differences when you want to flash on the SD card. I hope you enjoyed and learned from this video. This is for today, and see you in the next time. Thank you for watching, and bye-bye.